Welcome back to another episode of the EpicEarth podcast. EpicEarth is a podcast for those curious about the STEM fields and the awesome, quirky, and fun experiences and research that is taking place right now. This is episode number 22, the Glacier checking account. So hit that like, follow, or subscribe button, then sit back, relax, and enjoy the ride as we take a journey around this epic Earth.
I found it all so fascinating, just learning all the information.
Nobody told me I couldn't do it, and I loved it.
And now I know how to learn. Like, this is a doable thing.
You know, that's an impact that we can't ignore.
Welcome to another episode of Epic Earth. I'm your host, Ashley Bosa, and with me I have my co-hosts, Brian Rosenblatt.
Hey everyone, super happy to be here.
And we have Scott Galvin joining us again today.
Howdy, folks.
We're so happy to have you back, Scott.
Happy to be here.
It's always awesome.
That's my line.
Oh, sorry. I'm excited to be present.
Excited to be present.
I'll let that slip.
Nice. Got to work on our call lines or something. I don't know.
Yeah.
So before we get started today, I just wanted to announce that Brian and I actually just attended a nice sort of panel discussion. I believe it's called Keywords in Common, which is a new thing that BSU is sort of putting on, and more appropriate, the College of Arts and Sciences, and we now have the School of the Environment, which is being developed here at Boise State. And so this is a brand new program which just got approved, and it will have some new degrees, but it's really a interdisciplinary sort of program that's designed around, obviously, the environment and a lot of the disciplines that go into that. So, but having said that, you know, a lot of people might only sort of narrow the School of Environment to areas of study like biology or geoscience, which deal a lot with the environment. But at this panel discussion, it actually was a whole range of people. There were 5 people who were on the panel discussion. So there was Brian Jackson from the physics department. There was Dorsey Wanless, who is from the geoscience department. Then there was Libby Lundstrom, who is in public policy for ecology, which was really cool. There was Seth Ashley from communications and Helena Alvarez from human environment systems. And this is either professors or PhD students or other graduate students who come and do these panel discussions. And so the topic, or the key word for today, was Earth. And what does Earth mean? And so it was a really interesting conversation using all these different disciplines and learning on how people view what Earth is and like the definition of Earth and what it really means to them in their sort of disciplines or their research or their life. But obviously it means different things for different people. And we'd be interested in hearing what other people's definitions of Earth are to them. So I'm going to put maybe a little survey on our website and on our social media and maybe just get some input. Brian, do you have anything to add?
Yeah, I agree. I mirror everything that you say. I think it was very fascinating just to see how the word Earth, or what the word Earth means across various different disciplines, how that was similar and how it was different. And one of the overarching themes of the entire thing was that the Earth is essentially a living organism. It's a giant, massive, living rock that we're all on. It's flowing, it's moving all the time, it's never stagnant. And maybe we can do a better job of just listening to what the Earth's telling us, having a better relationship. Thinking about the Earth as being alive allows us to have a more equal relationship with it, give what we take from it and take what we give, basically, and just like how you treat any relationship with someone that you respect, basically, and we should all respect the Earth. So, yeah, I thought it was very enlightening, but I'd love to hear everyone's different thoughts on what the earth means to them, or what the word earth really means. So
yeah,
and actually going off of that a little bit more, it's interesting that we can say the earth or we can just say earth.
Mm-hmm.
Like earth has a name, like it's a person. Like no one calls me the Brian, I'm just Brian, and the earth is just earth, capital E. Like it really is, like we named it, you know.
Mm-hmm.
So
yeah, that's very true. It's an interesting sort of topic of conversation to have. You know, our podcast, EpicEarth, like that can mean a lot of different things to a lot of different people, and it does. The people that we interviewed study it in so many different ways, and I think it's a cool way to think about it. I also want to go off of what you were saying, Brian. Another interesting thing is like that I got out of the discussion is that, you know, the earth is vast, it's huge, it offers us a lot of resources and valuables, but it's also really tiny. And if we think about it in the context of, you know, the solar system or the universe, you know, how do we use Earth to sort of explain things, processes which are happening on other, you know, planetary bodies, or how do we fit within the universe as a whole? And I think that's just a really interesting topic that they sort of touched upon.
Existential crisis incoming.
Yeah, right now. Oh God.
And I hate to be that guy, but Earth, technically, its first meaning was derived from dirt.
Mm-hmm.
So Earth is dirt.
Yeah, so there's a very literal definition of it.
Yes.
Yeah.
I'm very oversimplifying here.
Yeah, you are oversimplifying it, Scott.
Yeah.
But we love it, so
and
keep it simple.
That's also a part of it, right? If
Yeah.
you ask like maybe a business major, what does the earth mean to you? They might say, oh, that's the ground I'm standing on. Like it's just the dirt below me. Like that's maybe their thought process on it. So
yeah. So so this is already a great topic of conversation, but we'd love to hear everyone else's thoughts and get your opinions about it, and maybe feed that back into the School of Environment and let them know, you know, how people outside of BSU think about the Earth. With that, I'm going to introduce our next guest. We're so happy to have this guest on our podcast. He is super cool. He is studying glaciers here at Boise State. He's a master's student in the geoscience department, working with Ellen Enderlin. And he came to BSU not too long ago after completing his bachelor's degree in geomatics engineering from his home country in Nepal. So I'd like to welcome Aman KC.
Hey everyone, happy to be here.
Oh, we're so happy to have you, Aman. We were sort of all having a discussion with Aman beforehand, and I'm going to have him reiterate what he was saying. So Aman KC. So KC is an interesting sort of last name. Can you just explain to us a little bit about where that comes from?
Yeah, sure. I'll also share an interesting story that happened to me in Switzerland, because they have this different pronunciation style than we have here. So I was in a conference in spring of this year, and the immigration officer looks at my passport and says, "Oh, I'm on." I was like, "Oh, maybe that's not the proper way to say it, but it's KC, just the letters KC." And every time I say, "Okay, what's your last name?" they say KC, and they're like, write CASEY, KC, which is funny. How it originated is, I'm kind of confused as well, but I can give you a little bit insights on that. So KC stands for something. It's an abbreviation of, it stands for Khatri Chetri. So in Nepal we have this caste system which is more broad, and which was made sort of like the occupation that you have in the past. So the priest would have one caste, the people who would work with iron would have one, gold with one, and we're supposed to be the soldiers, warriors that fight in the field. And so C stands for that, and K, which stands for Khatri, is more like species of that. So it's interesting because my grandfather has a different last name, which is just the K part, which is Khatri. But after my father, I don't know how it got changed, but yeah, it's just Casey now. And yeah, I really like it.
Yeah, it is cool. You're a warrior.
Oh, yeah, if you say so.
How often do you get the last name?
And that was the only time I've got
Okay.
it. And I should visit more German countries, I guess, to like get more of it. But that was the only time I got it. Yeah. Or should I should travel more and like see how they interpret the last name. Yeah.
Yeah, that's really interesting, and it's funny because I think in our discussion about what Earth means to people, a lot of that is language based, right? We were just saying the literal definition of Earth, where it came from, but yeah, our languages and the origin of our languages and our names especially, they take on so much meaning.
Oh yeah, yeah. We were part of this very interesting discussion at the conference in Alaska. It was International Glaciological Society annual meeting, and so the first speaker, the keynote speaker, was one of the members of the tribe from Alaska, and he started I think which was very powerful. Like he started just like speaking Tlingit, which is the official language of that, like their language, and yeah, I think it was very powerful. And he started by saying how they got colonized and like how they changed, because they had names for every glacier, every landscape, every mountain, and they all got changed into the person that like basically colonized, found it,
quote unquote, discovered it, but didn't really discover it.
Yes, I guess.
Yeah.
So yeah,
we're good at that. We're good. Yeah, that's really interesting. Well, thanks for sharing that with us.
Oh yeah, of course.
And that kind of segues into our next question. Tell us a little bit about yourself and what makes you, what makes you you, basically.
And now,
what makes you you?
I'll give you a very universal answer because I think it defines everyone, because all the things that have happened in my everyday life makes me. And I'm talking in the present tense because even my past choices were present at the time. So all the choices that I make, all the things that inspire me, all the things that distract me, define me. So if I try to mirror with my life, so the choice to pursue a graduate degree in order to understand the Earth processes and trying to be a wannabe geoscientist define me. When I look at other works of other people that do so much with so little, inspire me and strive me to become a better person. And all the negative energies that I often with highlighted I often face distract me from achieving my goals. So even distractions define me. So to sum it up, my choices, my inspirations, and my distractions define me.
So what you're saying is that every time I come down to your desk with chocolate, I'm defining who you are as a person.
Yeah, basically, yes. You are the source of inspiration, Ashley.
Oh, thanks.
Chocolate. Yeah.
I'm glad I can be a source of inspiration.
Oh yeah, that's the only good thing about my day. I'll wait when Ashley comes with the chocolate.
You need to do it more often. Or maybe not.
Yeah, maybe through this podcast, other people would come visit me more with the chocolates.
Oh, yeah. Hey.
Whoever is listening.
Aman really likes chocolate.
Anything, basically.
Yeah. Food.
Gifts.
Drop your cubicle number.
Yeah.
I don't know that.
Nobody does.
No, nobody remembers their cubicle number.
We are called Cryosphere CD, CT, I think. Yeah, the cubicle. They have names for each cubicle.
Oh yeah, that's right, they do.
Yeah, and we are Cryosphere.
Cryosphere?
Yep.
There you go.
So is your cubicle a sphere then? Sorry, that was stupid.
That was good.
Is it always cold? I don't know.
Yeah,
it is always cold.
I thought cubicles were supposed to be cubes, not spheres.
Yeah, we should cryocubes.
Yeah, cryocube. Yeah.
Cryocube.
Isn't that just an ice? It's not just ice.
Ice cube.
Yeah, we have a freezer where we store samples on the 4th floor of our work building, and I wonder if your cubicle's just inside that freezer.
No, or you're suggesting us to move there.
Perhaps.
Okay, we'll get it off your side, Scott.
All right.
Yeah, prove that with the administration coming up. Anyway, that was a big tangent to
who I am.
Yeah, even this distracting conversation is defining a month.
Yeah, see?
In all of us.
Uh-huh.
So getting back on track, what made you interested in this field of study, and how did you get into this type of work?
If I go way back, I think I still remember, and I still write it as my, the motivation that they ask for, why do you have that? And I think it's very common, it's very universal for me. Because if I go way back, I remember the deviance in weather patterns strike me as a child. So I can still remember one year we had this extreme drought, like extreme drought, and at a time, and it was a time of year which was supposed to be monsoon, and people rely heavily on rainfall to like for agricultural stuff, opposed to here, which is more irrigation, and for the rice production, like rainfall is very critical, and so yeah, I was like, well, why is this happening? We at that time we read in our textbooks about like global warming, climate change, and that was the first time I was experiencing it in my hometown, and yeah, that kind of motivated me to search for any possible fields of study where the research could help, like mitigate or like understand the problems more. And yeah, this curiosity led me to the field of geomatics engineering, which I did for my undergrad. And yeah, but it's very interdisciplinary, I would say, field of study, and has many aspects to it. But I really liked the part of remote sensing and Earth monitoring and processes. So yeah, for my graduate degree, I was pretty sure that I want to incorporate the remote sensing aspect and monitoring Earth changes. So
that's awesome. Can you explain a little bit about what geomatics engineering is?
Yeah, sure. So geomatics, so geo stands for like more Earth, and matics is like mathematics. So it's more like a measurement of Earth. And so it can be like from field scale, you do surveys, and you can fly drones to measure Earth, and to satellite images to monitor the Earth. So yeah, but they have like different aspects to it. There were some civil engineering aspects that we learned, some cadastre, like the land use planning stuff that we have. Yeah. But yeah, of all that, I was really interested in doing some sort of analysis using satellite images for monitoring Earth. So yeah, that's how I'm here now.
That's great. And like, how did you get to Boise State? How did you know Ellen Enderlin, or how did you meet her, or know about the sort of cryosphere research going on here?
So I think after my undergrad, I was doing my research, which was more heavily focused on agriculture and forest monitoring, but I always wanted to do some sort of snow or cryosphere stuff. And I did my undergrad in a very beautiful city called Pokhara back home. And like it's on the lap of Himalayas. You could like wake up and see the mountains, snow-capped, which are not anymore. So that's one of the factors that really got me into cryosphere as well, because I had seen the photos and I had not visited the city. And the first time I visited was during my undergrad. And when I saw the mountains, they were not like the pictures that I saw when I was a kid. It was rocky, bare, without any snow, like minimum snow at the top of the mountains, and I was like, this is not what's supposed to happen. And so yeah, I think that's what got me into cryosphere.
How did you find out about Ellen?
I think it was from Twitter, actually. She announced that she was looking for a student who's supposed to work with glaciers in Kalaallit Nunaat. Now I'm trying to pronounce it correctly, but it's Greenland. Now we know it's Greenland, but Kalaallit Nunaat is the Greenlandic language. And yeah, and she said in the Twitter post, it was clear that I was working on glaciers with some remote sensing, and like it was collaboration between different collaborators, which I really like. And I was like, okay, maybe this is a fit for me, and I applied, and I guess Ellen was interested to take me as a student, and I'm here. So it started with a Twitter post, some emails back and forth, some interviews along the way, some international application hurdles.
Yeah.
And yeah, then acceptance and fly to Boise State. And this December 16th, it's the anniversary of me being in the U.S.
Nice.
Yes.
We love it.
So did you know that you wanted to come to the U.S., or were you looking at other countries as well?
I was pretty broad, but I really like the grad culture of more North American universities like U.S. and Canada because they're more research intensive.
Yeah.
And yeah, I think either U.S. or Canada was one of my choices for my graduate, but I think in my in one part of my mind, I was more leaning towards the U.S. because, yeah, it's the U.S.
Well, we're happy to have you here. You bring such a unique perspective, not only from your own culture, but just a worldly perspective on things that maybe a lot of students who go to Boise State or a lot of U.S. students don't get to experience. So we're happy to have you here.
Oh yeah, I'm really happy to be here as well. And I was thinking about this, being a fan of the podcast. It's interesting, listening through the years in your cubicle now with you guys talking behind the mic. Oh yes,
it's a different perspective.
It's a different perspective for sure. Not as chilling as listening.
Oh, good.
Yeah. Stress. I should talk properly.
Well, you're doing a great job. And honestly, it's more of an honor for us to have you on the podcast because, we're excited about your research and you're an amazing person.
Oh, thank you, Ash.
So speaking of research, you work with Ellen, and you work in Greenland. And so tell us a little bit about what it is specifically that you're researching there.
Yes. So as I said earlier, cryosphere is very sensitive towards changing climate, and it's really important to monitor them because the effect in changing snow patterns or even glaciers can have very large impacts on the ecosystem downstream and on a global level as well. So for my research, I'm looking at the glaciers in Greenland to basically quantify how much ice we lose from the terminus, which is the part of glacier with terminus into the ocean. And specifically, I'm looking at the tidewater glaciers or marine terminating glaciers because they are under the influence of not just the atmosphere but also the oceans. So yeah, they can get affected by warmer air temperatures and warmer ocean temperatures. And it's kind of a feedback because more ice into the ocean makes freshwater ice into the ocean makes it more or less salty because it's the fresh water, and the warmer water kind of interacts with the glacier's surface or the face of the glacier, and it can melt really easily. So it's they're all related, but I guess it's really important to quantify the amount of ice loss that's occurring at the terminus. So I'm using satellite images and huge data set from a whole lot of different authors to quantify how much we lose ice at the terminus of the glaciers.
And how many glaciers approximately are you looking at?
So for now, we are planning to around 60, but we narrowed it down to now 56.
Okay.
Wow, from 60?
Yes, because
so many.
Oh yeah, it is. It is huge. It's a huge project, but we're thankful to the researchers that did a lot of work before us because we have the foundations and the data set that we need. It's not enough. I guess the data sets are never enough, but
sure.
it need a lot of filtering, which is taking a whole lot of my time.
Do you know approximately, are those all the marine terminating glaciers on Greenland is what you're looking at? Or do you know approximately how many there are outside of your data set?
So there are many glaciers. I think there are also peripheral glaciers, which do not terminate into the ocean as well.
Okay.
So but I'm specifically looking at the marine terminating glaciers, and how I have chosen the study sites is based on the data set that we have.
Okay.
Because we need the bed data, so it's basically the bare Earth model as well. And for these 56 glaciers, they have radar constrained bed elevation data instead of just extrapolating based on that data set. So because we're doing for the first time, so we're trying to choose accurate data as possible. So so these are the glaciers that were chosen based on the data availability and the quality of data.
Cool. So of those 56 glaciers, how do you sort them by any common characteristics? How do you wrap your head around 56 different dynamic pieces of data which all have their own metadata about them?
Yes. I think you get into it after you work with 56 of them.
You just remember everything about those glaciers.
I'm not in that position yet, but I think I'll be there like when I'm done, because I'm just working on 3 of the sample glaciers for now. And if I get the code running and if I get the data, which makes sense, then I can delve into more of that. But yeah, I think the thing is, the different data set have good metadata that helps kind of navigate what it's telling.
Oh, okay.
So I think that's helpful.
So would you say your terminus is always shifting?
It's always moving, to be honest. It's never stable.
Are any of our terminuses ever stable?
I doubt.
The end game is always shifting in some way.
So that is like a lot of glaciers, but I mean, like in general, we're all standing on the shoulders of other people. So like all this data that you're using, you're not directly collecting that. Like that's from other people's efforts to get that data, and plus other people they're probably doing research or have done research on some of the glaciers you've looked at in the past, and in the future people will also like pull some of the stuff that you did to build off of that as well. So I mean, thinking about it like that makes it seem a little more manageable than like dealing with 56 glaciers, just like trying to look at it all on your own. Like I want to talk to you about what you said about glaciers melting, and those glaciers wouldn't have salt, so essentially the specific heat of the water in that area would be lower, so it could get to a higher temperature easier or with less energy. That's my understanding of what you said. Basically, less salt in the water means that the water can heat up with less heat energy. Is that, you might not be able to answer this, but is that just like concentrated around the terminus, like in those areas the amount of salt in the water is less? Or does it just basically mix in with the majority of the oceans and it's, yeah.
That's a very good question. And it's more of like the oceanography side of it, because it just deal with the inland or like the land part of glaciers. But I would not be surprised to see the results because even the temperature, it's like if you go a few kilometers outside of the terminus, then it's drastically different from the ones like that are close to the glaciers. And even the ecosystem, like the plants, the phytoplanktons that they have, the fish habitat, because it's really impacted by halibut, which prefer, like if the water is too warm, then they would migrate towards more north and side. So I cannot give you a very definitive answer, but I'm pretty sure that they do have some sort of variability, spatially. If you look at more like near the terminus, outside of the terminus. And they're like this huge ocean currents as well, like that go around the coast of Greenland. So I think that do a lot of mixing as well. But again, like I'm not very expert in oceans, but you know, it still varies.
Oh, that's awesome. Great, thank you.
But it's a very valid discussion, and even at a localized level, you can have a global effect. So we're talking about these huge currents that actually circulate around the entire Atlantic Ocean, and those affect weather patterns. They affect, you know, things happening even at the equator. That travels upwards, and that can affect a lot of the stuff happening around Greenland and everything. They're not exclusive of each other, right? Like stuff happening at Greenland is impacting what's happening in those oceans, and same the oceans. What's happening in the oceans is impacting what's happening on Greenland. So.
That's why it's like the feedback loop. Like you get like oceans affecting Greenland, and I guess ice sheets affecting oceans. They go both ways, and so they have the projections like if all of the Greenland melts away, the global sea level would rise by around 7.4 meters.
Wow.
Whoa. That's
just the Greenland ice sheet.
Not even the Antarctica.
Wow.
So because in the if you go to the center of the Greenland, it's like kilometer wide the ice sheet. So.
Wow, that's crazy.
That's why it's concerning.
That is very concerning, and it's important to recognize that everything's interconnected. It's you know, there are things happening which we may live really far from the ocean here in Boise, but what happens there is impacting even our own climate here in Boise.
I read an article which I showed in my proposal presentation a few weeks ago. Like all the small Pacific nations, though they are like far, far away from Greenland, which are in the southern hemisphere, they are getting really affected, and how they are really concerned about like losing their home, basically losing their country.
Yeah, I mean, most of those islands are probably less than 7 meters high from the
Oh,
ocean
yes.
base. So,
And before the last like glacial maximum, there's a lot lower of sea level, so that apparently a lot of past civilizations might have been lost from sea level rise, and we could be next.
yeah.
So if there is this negative like feedback loop, does that mean everything is accelerating? Like year after year, there's more melt, or are things like getting worse over time if there's this feedback loop that's occurring, I guess?
So I think the things got worse around from 1990s. So it's been losing mass since the 1990s.
Okay.
So there's not been positive side of it, like because there's accumulation and ablation. That's what makes the glacier. So basically, ablation is occurring more than accumulation. But we do, like in some years, we do see some spikes.
Okay.
I think in 2013 there was a huge negative balance. And in 2022, Greenland melt season had the record-breaking spike in September. The melt season was like, if you look at the graph, like this is like, it should be around this temperature for the month of September, but it ended up being like huge spike, and it was like the most melt Greenland has ever experienced in September.
Wow.
So it's very unpredictable as well.
Well, yeah.
There's a lot of variables that go into that equation, like.
Oh yeah, that's why I think it's, the more I study about it, the more sure I am that we do not know much about it.
Yeah.
Yeah.
Because.
Oh, it would take at least your lifetime to figure out even some of the.
Oh yeah.
Like simplest of things that happen. I mean, they're such complex systems, right?
Oh yes.
So it's hard, but what we do know is that melting of these glaciers is impacting things globally.
Yeah.
And we can definitively say that for sure.
Yeah. I agree. Yeah, and it makes me sad. Like the more I look at the time series, like, oh wow, we're losing ice.
Yeah,
like,
I feel like being a glaciologist is a hard one because everything, like on a geological time scale, everything is happening like almost instantaneously. It's happening on such a short basis, and it's like, how can you not come out of your grad program or out of that career just feeling really depressed about where the Earth is heading? But we're lucky to have people who study it and who really understand like just the impacts that it's having and the influence that it's having.
Oh yeah, I have a friend who studies like basically changing lifestyle of people in Africa. From because they are the ones experiencing the worst weather patterns.
Yeah.
And they are the ones who emit like almost nothing greenhouse gases, and they are the ones who are experiencing it. And I'm glad I'm not in that shoe, like because she's going out in the field, talking with people, like she has to listen to all the stories and how their life is just basically very difficult with the changing climate. So, it's even more depressing for those folks, but.
Yeah, absolutely. And we just live in our bubble.
Oh yeah.
We all live in our bubble, but it's nice to sort of, well, not nice, but it's important for us to hear about like those types of scenarios, right? Like,
yeah.
It's all well that we drive our cars and we get upset if we don't get our Audi Q5 from the rental company or whatever, but in reality we have to remember that there are people in much worse situations than we are, and actually that what we're doing is really affecting them even more. So.
Yeah.
I think what's like super key there, and like it's very ironic, but what you said is like the people that are emitting or adding to the problem the least are experiencing the worst of it.
Yeah.
And like that's just very like ironic, and like it propagates the problem even more, I think, because if we were experiencing more of it where we were causing the problem, we'd directly see those changes. But it's like that, what we were saying at the beginning, the scale of the Earth sometimes is so large that you don't make those connections. You're in your own little bubble, and
yeah, I think that's the story about the people in Greenland as well. Yeah, Yeah. Because they had to change their hunting patterns, their fishing patterns, and like everything, the life they had been living for generations, they had to change because of the unpredictability of the weather now.
Yeah. And I mean, humans are quite resilient. We have been able to adapt to climate change before, but on the scale that it's happening so rapidly that it's at this point where it's hard for us to adjust so quickly.
Yeah.
And so, yeah, it's interesting to talk about how cultures and peoples are adjusting to all these things which are happening, and sadly, it's, you know, they're having to do it because of like the human influence on this. But yeah.
But on the good side of that, at least, like there are positives coming out of it, which is like there's union of cultures, like to work on a problem together, like like we're all working to hopefully in like a global sense try to fix this problem in some way. And like it's kind of like if you think of like a metaphor, like it's a stream, like the civilization that's at the like earlier part of the stream, they can take out as much water as they want. They won't really see the effects of the less amount of water down the stream or whatever. And like we just need to work together with everyone who's using the stream as a resource to make sure like the stream is healthy and everyone is taking like their part out of that stream, I guess. So
yeah, that's a very good analogy.
Yeah.
And I also appreciate the researchers that are working with communities now, because I think before it was kind of very isolated. The scientific communities were doing the work, but the communities who live on that land were not part of the research.
Yeah.
But now they are like being taught in the process. They are involved in like helping the research. So I think that's also the positive part of it.
Yeah.
I agree with that.
Yeah, we've been talking about that a lot, citizen science and stuff.
Yeah, the citizen scientists. And even in our own field work, you know, the social aspects of that work, how does it impact people socially?
Yeah.
You know, we know people who go to volcanoes and talk about eruptions for communities living around those volcanoes, and it's really interesting to hear their perspective too. You know, I think we're moving away from the white knight sort of savior. We're coming in to do science and we're going to make things better for you. I think the sciences and the STEM fields in general are shifting away from that perspective, because what we've learned is that the locals know way more about this stuff, and they have really unique perspectives on those processes that we may not know about or we may not experience. And so like their perspectives are very insightful, and they really do advance the technology, because really that's the reason why we're doing the science, right, is to help sort of understand and facilitate our understanding in those processes, but also to help mitigate some of the risks and hazards that are being sort of propagated through either Anthropocene or natural hazards.
Yeah, I completely agree on that. And they also can provide insights on the things that we cannot solve scientifically, like with the scientific understanding. For instance, like I can think of what about the time period before the satellites were up?
Yeah.
How do you know where was the glacier before that? You can do the modeling, but it's the model. It's not the human input.
Right.
But you can always ask the community. They have lived through generations, and they're like, oh, this was here in 1975, and now it's retreated by a few kilometers up there. So I think it's always very fruitful to help have the community in the discussion.
Yeah, this is an excellent conversation. And something that should continue. So kind of shifting back into your research, and maybe on a lighter side of your research, what is the best or most fun thing that you do regarding that?
I would say like using just basically satellite images and harnessing its power to to better understand the processes. And stories like this, it really inspire me to do more, or like get in the studies. And yeah, reading about the stories, it makes me sad, but also at the same time, I feel better about myself, because I am like doing studies in these lands, they are really significant, they're really important to the people and to the whole earth. And I also read funny stories about polar bears, penguins, which I'll share. One of them, I think, which is very, very nice. So polar bears, which are only found in North Pole, and they normally use sea ice to hunt. But due to the current reductions in sea ice, so they have relied more on glacial ice now. So when icebergs, or basically when a calving occurs, like the icebergs detach from the glacier, they would be out in the ocean, and with the like sea ice, some of the sea ice that they have remaining, and this glacial ice that discharged, they would form sort of actual sea ice. And now the polar bears kind of rely on this. And this study was conducted in southeastern part of Greenland, and they also found, I'm not very expert in ecology and like biology, but they had some like mutations in their genes because they relied more on glacial ice compared to the sea ice.
Wow.
So yeah.
Yeah,
I thought that was a very interesting story, but yeah.
Yeah, I mean, I guess over the history of the Earth, you know, it's not just humans which are adaptable. It's the whole cohort of like things that live on this Earth. So yeah, that's really interesting.
So yeah, I think the best part is like reading stories about polar bears would be the most fun part of mine, because I don't go out in the field because I'm using satellite images, but yeah, reading about the stories of people and polar bears, that's the best part of my job.
Yeah, that's cool. I love it. I love bears, so.
Oh yeah, who would not? Like,
yeah, if there were
unless you're in front of a polar bear,
yeah,
you
if
love
there
it.
were volcano bears, I'm pretty sure it'd be like the most perfect job for me, but I don't know that those exist.
What would that
Bears
even?
made out of magma and ash.
Yeah, be quite terrifying.
Terrifying conscious
I
mixture.
don't know.
of-
Maybe it feeds off of like organisms that live in those really hostile environments.
That'd be really cool.
Who knows? Maybe they do exist on another planet.
Oh yeah.
In my dreams.
Well, they're those little water bears.
Yeah, true.
Oh, the tardigrades?
Yeah.
I love those things.
Or you can take gummy bears to the field.
Oh yeah.
That's true. I'm gonna start doing that and just taking photos of the gummy bear next to the volcano. Be like, volcano bear!
You should rename that, the gummy bears. To
Yeah,
volcano
it's gonna be a thing.
Write a letter,
Yeah,
actually.
when I'm world famous volcanologist. It'd be like the Wheaties boxes, remember? They used to have like the famous people on the boxes.
Would it be really famous if you become a volcanologist?
No.
Yeah, so like, sing,
Yeah.
dance.
Yeah.
No.
Do it
Fire
on
up the
TV.
conspiracy.
I mean, I have to do something pretty crazy. I mean, I guess that is kind of crazy. They'd be like, look at that weirdo with the gummy bears and the volcano. That's-
Oh, yeah.
I could see you going viral for that.
Yeah, that's true.
Have a TikTok.
Yeah.
Doing it.
Yeah.
After this podcast, my next big thing. Okay. If you could describe your work using an analogy, Aman, what would it be?
It's a very interesting question, and I think it would be quite relevant being a grad student, because it's what we face and how we deal with it, and I think it's really relatable. So a glacier is like a checking account. It has an income in the form of new snow, and there are expenditures in the billions of gallons of water it loses each season. So think of it like when you have, you as a person, you have a bank account and you go, I don't know, more hotter climate, like beaches in California or like Florida, then you would have a better chance of negative balance in your account.
That's for sure.
In contrast to like in winter where it's snow and you do not have much to go except for like if you're really into snow sports. Other than that, you're basically inside home and doing basically nothing. So you would have like accumulation over winter. So if you think of it as like, if the glacier is exposed to more hotter climate, then you would have more negative balance. But in contrast to winter and snow, it would have more positive balance.
I love
Does it
that.
make sense?
Yeah.
Yeah, absolutely.
If I were a glacier, I'd be on the surface of the sun because I am constantly spending money.
Just negative
I
balance.
feel you on that,
all
Scott.
the time.
It's not enough.
Love it. That was awesome. Yeah, I think that's a good way to think about it.
Fantastic analogy.
Mm-hmm.
Yeah, because I've heard being a fan of podcasts, like so many interesting stories, and I think this was the question I thought about the most.
Yeah.
Because
most people
so
say
much
that.
pressure, like nailed it.
Nailed it. You really did.
Oh no, I'm not taking that meat.
Oh no, you did. No,
Fully
you
nailed it.
you definitely nailed it. That was probably, one of the better analogies for sure that we got.
You're not saying that just because I'm here?
No.
Okay.
Most people have a bank account. I don't know. Or not. I mean, it's better than a checking account. I don't think people know what checks are anymore. They're like, what's a check?
I have a checking account.
I have a checking.
I mean, I guess they still call it checking accounts,
Yeah.
but yeah.
I do have a checkbook that I haven't touched in probably 2.5 years.
So do I.
3
Yeah.
years, or
It's
maybe
not. It's
longer.
obsolete. It's not a thing anymore.
I've not touched it since I last moved out of my last place because it was so weird. My landlord, she wanted the check.
Oh, that's annoying.
And she lived in Pennsylvania.
Oh my gosh.
Wow. Yeah. That's even a more insecure way of getting money.
Yeah, we could sell you, no?
Yeah, like Venmo, you get there in like a day.
Mm-hmm.
Yeah. Oh, these
weird
old
times.
generations of people and their checkbooks. How dare them?
Boise rental crisis.
Yeah.
I lived through it.
Yeah.
Okay, so let's see. Now, I know that you do remote sensing, but do you have any fun stories from the field or being outdoors that you could share with our listeners?
Yeah, so because I mostly work behind the computer screen, so I've not gotten a chance to yet visit Greenland, but if I ever got a chance to visit one day, I think it would be amazing to see them.
Mm-hmm.
And I know they're massive, and I'm pretty sure experiencing them would be satisfying and amazing.
Yeah.
Because you look from a perspective of satellite image, you think like it's, you like delineate the boundary and like, oh, this is a thing, but when you calculate, it's like, 5 kilometers of retreat. Which is huge. And so I do not have stories from my grad field trip, so but I do have a fun class trip story from my undergrad. So we went to this class trip where we were supposed to see some weather stations and more of the datums that they have, and a couple of us, like 10 of us, decided to go to a mountain that was nearby, and none of us had seen snow before. And it's ironic because being from Nepal, everyone assumes that I camped down the Everest. Like, oh, where are you from? I'm from Nepal. Oh, how many times have you climbed the Everest? It's not like my Everest is up in the school.
Do you mean everybody, or do you mean just me? Ask you that question all the time.
No, actually, I've been there a couple of times, so. And I don't think you asked that.
No, I didn't. It was not out of ignorance. I was really just.
Yeah, it's ironic. They assume that I camped down the Everest and climbed to the summit for my school and come back again.
That's what you do for school.
Yeah, just climbing the Everest.
Oh, God.
Casual.
Yeah, so, and my hometown is way, way south, and
different.
The only form of snow that we see is rain, so.
Yeah.
So we were really excited about getting to the mountain. We went there, and it was supposed to be 2 days trip, but we came after 1 day because we did not see any snow. And we went to the northern part of mountain because it was more shady and you could see the snow. But by the time the snow has all melted, and where we got to by the end was teeny tiny, by the end of the tree that we have, protected from sun. We made snowballs and took pictures, crushing it and make a fake snowfall. It was pathetic, but when I look at the pictures now, it's funny.
Have you seen more snow in Boise than you did?
My entire lifetime, I'd say.
Wow.
Yeah, if you count from a distance, then I've seen a bunch of mountains, but I've never been to a proper mountain. So, yeah. And also I have a cool battery story that I have. So after my undergrad, we were doing some sort of work, and because we need to charge our machines and with the batteries, and what we used to do, because we were out in remote, we used to charge in hotel rooms during the night. So one day we forgot to charge our batteries, and we did not realize until we went out in the field, and it was dead after 5 minutes. And
Rookie mistake. No, actually, that happens to all of us.
yeah, and what we ended up doing was, I think, which was very good and a different perspective. So what we ended up doing, and at that time I realized the importance of local people. So what we ended up doing was spending time with local people. Because before that, we were there for 5 days, but we were just like doing engineering work, just surveying, just doing our work. But on that day, we actually got to meet with people, chat with people, and like see how they live day to day, and we also got to experience, taste some of the foods, how they prepare it. So yeah, it was like a very wholesome experience. So I think that was really fun part of our field.
Yeah, the most rewarding,
Oh
probably.
yes. So if I look back to that time, I can't remember what I did with the field, like measurements and stuff, but I can still remember the stories, spending time with that families from that part of the country. So
That's awesome.
yeah.
That's really cool. Okay, I'm gonna sort of shift gears a little bit and ask you our first serious question, quote unquote.
Serious question.
Buckle up.
Yeah, I know.
Time of the seatbelts.
How would you solve a scientific problem if you were from Titan?
Yes. It's an interesting question. So Titans, they are this moon of it's the moon of Saturn, Jupiter. Saturn. Okay.
Yeah.
So they have. I found recently that they have this cool rivers. I don't know if they are called rivers or not, but they are methane, not water. So because we have so much greenhouse emissions from our planet, like, what if we just like store everything in the planet that's already methane? Like, store some beers there so that we don't have to open up our fridge every time and we release the greenhouse gases every time.
Yeah.
So it's the planet that already has methane and it's really cold. We just store some beers, drinks, anything you like to make, and come back to Earth when you want to drink it. So
there you go.
I don't know if it's a very good answer, but we can still, if I'm trying to think that way.
Yeah, I love it. I love the idea. Our last guest said that she would just put Christmas lights up on Io. So, I mean, she would just decorate Io with a bunch of Christmas lights. So I'm loving this idea of using other planetary bodies to to just our own agenda.
We also have
because we're human.
rains and stuff. So what do you call it? Meth rain. Oh, they do not.
Oh yeah.
They do not come up good.
So that's really funny that you brought up Titan, because today I actually just learned at this panel discussion that Titan, if it were orbiting the sun, we would consider it just another planet of our solar system. It's that big, and it's so dynamic, and it has all these different. It has, those rivers or fluvial systems of methane. It's got rolling rocks. It's got mountains. It's got it's crazy.
Yep.
So that's really cool. And great answer, by the way. I'm sure a lot of our listeners will agree with you.
Okay, I hope none of astrophysicists are like astro. This episode.
You know what? It's okay. You're a glaciologist working on Earth analogs, so.
Yeah.
I mean, we like to. Part of the purpose of that question is to see the creativity of geoscientists and to have you think outside the box. Yeah. So
okay.
Yeah, so it's not just about the science; it's about using what we know about other places outside of Earth.
Okay.
There's no wrong answer.
There is no wrong answer, literally.
Yeah, I could make a Titan of my own.
Yeah.
That's true. You could just make up your own planet if you wanted to, or whatever. Okay, so jumping back into your research, we're going to do now the segment where we kind of give you the elevator pitch, or you give us the elevator pitch of what it is that you study, but to 3 different groups of people. So the first group would be like an elementary class or 4th or 5th grade class. How would you describe to them what it is that you do?
5th grader.
So yeah, if I'm talking to 4th or 5th class, then I guess I have to make them aware of what glaciers are as well, because they might know about it. So we know rivers as flowing water. So just in place of water, if we think what is flowing is ice, then those are glaciers. So glaciers are these massive bodies of slowly moving ice. Our planet has many glaciers around the world, and just think of like ice can melt really quick when it is out in the sun, in contrast to being inside a room. So yeah, glaciers, which are made of ice as well, can also melt really quickly if it is out in hotter temperatures. So what I'm trying to do is to measure and calculate how much ice are we losing from these glaciers. And for that, I'm using images taken by the satellites which are high up in the sky.
Nice.
Cool.
Yeah, that's a great explanation. I love how you sort of like have little analogies of like the ice and this is what happens when ice gets hot.
Yeah.
Awesome. What about to maybe an undergraduate student or maybe an older high schooler student who knows about glaciers but doesn't quite understand the research that you're doing? How would you describe it to them?
Undergrad.
Yeah, so if a person knows what a glacier are, so they are basically large accumulations of snow that eventually turn into ice and move down slope under the influence of gravity and their own weight. So these massive bodies of ice are affected by changes in global temperatures. And the glaciers that specifically discharge into the ocean can affect the ecosystem downstream into the ocean and has the potential to raise the global sea level. So what I'm trying to do is quantify the amount of ice loss from these glaciers, which are called marine intermediate glaciers, from Greenland using satellite data. And yeah, basically obtain a time series and see how much it has changed over the years.
Nice. That's awesome. And then lastly, your last group, which you've had some experience with, a professional at a conference. How would you describe it to them?
Expert.
So yeah, I think if I'm talking to a professional, I have to like sell why I'm specifically interested in this type of glaciers. So I'd start by like calving icebergs currently accounts for like 70% of the world's annual mass transfer from glacial regions to the oceans. So the previous studies have estimated the iceberg discharge at the terminus of glaciers, but it was more through calculating the amount of ice that goes through a gate. So we never know what's happening at the terminus. We never know what's the precise timing of the mass loss. And it can deviate from the flux estimates that we had before. So I'm trying to quantify the ablation occurring at the terminus, which we call as terminus ablation or frontal ablation. And yeah, I'm just generating a time series of terminus positions along with ice thickness and discharge using the gate method that we have, and see how they have changed under the influence of other oceanic forcing parameters like presence of sea ice and melange.
Nice.
Very nice. Well spoken. I was gonna ask, what is a calving iceberg specifically?
So yes, when I talk about terminus ablation that's occurring at the terminus, so there are three pathways the glaciers can lose ice. The first one is calving, which is like the detachment of icebergs. So you see in the videos, like boom, that's calving icebergs.
Okay.
And submarine melting is the melting that's occurring below the surface of the water because of the interaction between the warm ocean water and the face of the glacier. And some parts of the glacier would be exposed up in the air as well. So we would have the melt because of the interaction between the air temperature and the face of the glacier as well. So subaerial melt, which is the interaction between the air and the glacier, submarine melt, and calving. Okay. And these all are interrelated to each other, and like one huge calving event can trigger all of these.
Makes sense, yeah. Thank you.
Yeah, sure.
You're so knowledgeable. I
I'm
love
glad
it.
you think that.
Yeah, no, it's great getting people's like really like their research that they're really like into and that they've done a lot of work with, and sort of hearing them talk about it, and you are no exception to that.
Oh, thank you.
So this has been amazing. You are doing some really fascinating work, some really important work, and Boise State is so fortunate to have you doing the research for them and for Ellen. And so we're going to finish up your interview with some more serious questions.
Terrified.
Yeah, all the fun stuff. So your first serious question is, if you were famous, what would you be famous for?
Oh.
I'm gonna pose this to Brian and Scott too. What do you guys think you'd be famous for?
So I think I'd really like the artistic field of it, even though I have zero creativity. But I really admire people who have like creativity. So if I can be famous, becoming an artist that like, and we have this one artist on our project as well. I think I'm stealing his idea, but like to make maps of this changing Earth. I don't know if I'll be famous, but I'll be really proud, and like I would have some sort of satisfaction in the job that I'm doing. So, kind of like citizen science and like outreach, because the art can speak a lot.
Yeah.
So like if you talk about for an hour, or if you display an image that's powerful, then it will do all the work that we want to talk about. So some sort of artist painting, and like that basically shows what's happening on the earth.
Yeah.
Into that. I don't know if I'll be famous, because not most of the people care about it.
I'd pay $10,000 for one of those pieces, so.
Yeah, I think that's the thing I'd be really interested in.
That's awesome.
Yeah.
Don't cut yourself short. I mean, like figures are basically like art.
Yeah.
Like I'm sure you're creative.
Okay, I'll take it, Brian.
Yeah, no, you are.
That'd be in my head now.
I mean,
like, I'm an artist now.
Yeah, you are. I've done art with you. You're definitely an artist. You've got creativity, so.
And my answer agrees with that pretty well. Like, I don't want to be famous. I want to be well known and respected. Like, I don't want to be like on the street, like people coming up to me, like swarming me. Like,
you're telling people to do not do that to you now?
Oh, all the time.
Yeah.
Oh, you're that master's in geophysics student.
Yeah, I thought you were the one who like people crowd around.
Yeah. You're that one, yeah. Yeah, I know. That's personally my answer. But if I had to be famous, I guess it would be for, once again, like a societally changing action, like in a positive way, obviously. Yeah.
I could see that happening.
I don't know. Who knows?
Yeah.
Life's a journey.
I think realistically for me, I would end up being famous from like one of my musical groups or something.
Oh yeah.
But if I had it my way, I'd like to be famously known as like an astronaut or something. Just like, I mean, personally, I know like a lot of astronauts' names, so to me, astronauts are famous.
Yeah.
But
famous.
Yeah, and it's not the same level of fame as like pop stars or like that kind of stuff. Like that's a different kind of famous where like kind of like Scott's saying, like you're respected and like paparazzi's not like swarming your place or anything, but you're well known and
Yeah.
So. What about you, Ashley? What's yours?
Yeah.
Well, volcano bears, obviously.
Oh, yeah.
We've established what I'll be famous for.
Yes.
Forget about like the science and the outreach. Volcano bears, that's where it's at. And more seriously, I think, I guess just having that change of perspective of the world for people, and whether that's through volcano science and having people see, the impacts that those processes have, but also art. I would go with art. I'm actually more artistic, I feel like, and
you are the artist of our group.
That's well. I can't play an instrument to like save my life, but I will sit there and do art while other people make the woods.
Can you play an instrument?
No. I can like play them, but not in the rhythm.
That's okay.
I can like strum, but not in a song.
Yeah.
We're okay. We're into it. You could do art with me.
Yes.
Or make
while
maps.
I play the instrument.
Yeah. Or sure. Actually, that'd be kind of cool. Like do like a drum beat and just like put some paint on there and make.
Yeah. Oh yeah. We're getting famous.
Paint what the music makes you feel.
That's it. That's
we
right.
should start a TikTok.
Yeah. Well, we're gonna start a band apparently. So.
Okay.
Yeah.
So
We're close.
we'll be like the backup artists of the band.
Extras.
Yeah.
We need groupies.
Oh man, okay. I would be a science rapper.
There you go.
If I had
oh
to
my
be
gosh, yes.
Oh,
You're
that's
gonna come
cool.
up with next
Oh,
year's
yes.
theme. And I'm sure Aman could write the lyrics for you because he's already like
Please.
saying some theme songs for me that I won't pressure you into doing that.
Oh yeah, no pressure.
But I am going to pressure you into teaching us a couple of Nepalese words that we can use. So,
Yes, we can definitely do that.
so I'll let you choose the words.
Okay, I'll start with a word that's most common, like people know about Nepal, is the Everest. So Mount Everest, it has a different name in Nepali, so it's called Sagarmatha.
Sagarmatha.
Yeah, so it has a meaning as well, because I think most of the ancient languages have meaning instead of like just
Just
name
last
of a person.
names.
Yeah. So the Sagar means sky, and Mata means forehead. So it's like forehead above the sky.
Like that.
Some people also interpret it as the goddess of the sky as well. So
Wow. Yeah.
which
I love
makes
that.
much more sense than the Everest, to be honest.
Yeah.
The Everest.
Yeah. And the other word would be, I've taught Ashley about this. Maybe you can go ahead. What do you call a friend?
Oh gosh, no, you put all the pressure on me.
On the spot.
Sati.
Yes, it's called sati. So
Sati.
because we're all friends here, so I guess that's the another word that's really
Sati.
sati. Yes.
C.
So-
D or T?
It's like if you spell it out, it reads Sathi.
Okay.
Sati. Yeah, sati. So yeah, there are more difficult words. I don't think I should get into that today because we'll take a whole episode of that next.
Yeah. Learn a whole new language today.
Oh yeah.
You promise you're not telling us any curse words right now? I can go out and just say this, I'll be fine.
Well,
You should be. I can teach you one more. Not a curse word.
I was like, oh.
Yeah. I'm saying snow, maybe because that's what I study.
Yeah, that's a great one.
So snow is hue.
Hugh.
Hugh?
Hue.
Hugh?
If you spell it out, it'd be Hiun. There'd be like N would be you'd not pronounce it, but they would be
Okay.
Hue.
Hugh.
Yeah.
Oh, that's awesome.
Yes.
Does that have a particular meaning, or is it just literally?
It's the snow. Like,
Okay.
I think the monuments or like the structures would have the meaning about the names, but
Yeah.
it's just like a name.
A name. Yeah. Really cool.
Yeah.
Well, thanks for sharing. It's
course.
awesome. And yeah, anyone who wants to learn some Nepalese,
Yeah.
talk to.
$10 an hour.
Yeah.
That's cheap.
Oh yeah.
$10 a minute.
Yeah.
$10 per word is what you should do.
Oh yeah, of course.
Because we're grad students and we can afford stuff like that.
That's why I said it's so low because
Yeah.
people don't have money.
Especially Scott, apparently.
Yeah, he's out in the sun.
Yeah.
I make some life choices.
Well, Aman, thank you so much for doing this interview. You have been so awesome, and we're so happy that you were able to come on.
Oh yeah, thank you guys for inviting me. I'm really honored to be a part of this series, and hopefully I'll get to listen to it more, even when I graduate, and even you guys graduate. I hope you get the series going along.
Oh gosh.
Thank you.
Yeah,
We're growing.
Yeah.
we have all the merch stuff. Like we are officials now. So.
Oh yeah.
I mean,
all our swag.
speaking of this, we've been meaning to say like, follow, subscribe. Like, I don't think we've ever said that before, so.
Oh, yeah.
Yeah.
Do all that, please.
do all that.
Yeah.
And we're looking forward to hearing about everyone's conversations about what Earth means to them. So, thanks everyone for listening, and thanks to our guest, as always, Aman, for being here.
Yeah, of course, guys. Thanks.
Have an epic day.
Well, that was an epic conversation.
We'd like to thank all of our listeners.
Tune in next time for another Epic Earth podcast.
That was a good one.
Cool.
We like it when Scott's here because he always wraps it right up with his epic thing.
I'm always so awkward. I'm just like, all right, bye.
Oh, sorry.
Oh yeah.
You got distracted.
It's okay. It's all part of the process.
Yes.